Now, if you recall from last time, I mentioned that the reason I teach 11.8 early, as opposed to at the end of the chapter, is because it takes about a week to process these types of problems. So you need to make sure that you're practicing and you're watching the method again if you need to on the recording, and learning that chart that I've taught you, because it really comes down to that chart. Okay, so starting with number 13, in a product liability case, a company can settle out of court for a loss of $350,000 or go to trial losing $700,000 if found guilty, and losing nothing if found not guilty. Lawyers for the company estimate the probability of a not guilty verdict to be 0.8. Okay, so going back and writing down the key information from this problem. It's a product liability case. If they settle out of court, then they lose $350,000. Or they can go to trial. And so they lose, or a loss of $700,000 if guilty, and lose nothing, loss of nothing, if found not guilty. Okay, so the lawyers for the company estimate the probability of not guilty verdict to be 0.8. So the probability of not guilty equals 0.8. All right, so part A says find the expected value of the amount the company can lose by taking the case to court. You got to read that very carefully. Find the expected value of the amount the company can lose by taking the case to court. Okay, so we'll start with part A and get to part B in a second. All right, so notice that they have a lot of choices here. They can either avoid going to court and settling, and it's a guarantee that they're going to lose $350,000 if they settle. Or they can go to trial and take a risk. And so either they're going to lose $700,000 or nothing, depending on what the court finds them. All right, so notice that it's the expected value of going to court. That's the key. So any expected value problem, this is the chart that you're setting up. Outcomes, gain-loss, probabilities, and products. The only time you would not make this chart is if a chart has already been made for you, okay, like the insurance problems in your homework. Those charts were already made, so you don't have to make one from scratch. Okay, so if you see the keywords expected value, this is what you're doing. It'll always say expected value in the problem. So we are focused on going to court, or the other way they put it was going to trial. So what are the possible outcomes if you go to trial? Guilty or not guilty? Okay, and then consider that this is a case of product liability. So what that means is there's probably potentially a lot of people that are suing for product liability, or so there are many people that were either hurt by a product or something happened that way. So it's not just losing $700,000 total, it's for each case that's brought to court. All right, so if they're found guilty, we already explained that, a loss of $700,000. And then if they're found not guilty, then what's their gain or loss? Zero. Good, because it says nothing. Okay, the probability that they gave us was not guilty, so that goes right here, 0.8. So what does the other probability have to be? 0.2. Why 0.2? Because this has to add up to 1. Good. And again, if you're not good at visualizing what the other number should be, you can always say 1 minus 0.8. And that'll give you the 0.2. All right, so now that you have those 3 columns filled, now you multiply and add. So going across, multiply. Negative 700,000 times 0.2. Negative. Okay, somebody, one person tell me the digits. 140,000. Okay. Everybody agree with that? Okay, because I heard 100,000, 40,000, and I could not make out what you guys were saying. All right, so what's 0 times 0.8? 0, good. So then when you add this together, you still get negative 140,000. So that is your expected value if you go to court. Okay, this means over the long run, for each court case, the company is going to lose about $140,000 for each case that it goes to trial for. So then the question is, should the company settle out of court? The answer is no, that's correct. Why? Right, so you're expected to lose about $140,000 for each case because that means that most of the cases are weak that they're bringing against the company. But there might be a couple that, they have a strong case, so they'll lose a couple, but they'll win, most of the rest of them. If they settle out of court, automatically they lose $350,000 for each time they settle. So their chances are that they're going to lose less if they just go to trial. For many years, organized crime ran a numbers game that is now run legally by many state governments. The player selects a 3-digit number from 000 to 999. There are 1,000 such numbers. A bet on $1 is placed on a number, say number 115. If the number is selected, the player wins $500. If any other number is selected, the player wins nothing. Find the expected value for this game and describe what that means. Okay, so we have a numbers game. And the player selects a 3-digit number. From 000 to 999. Okay, they went ahead and told you that there are 1,000 such numbers. You could have figured that out, okay, because there's 999 plus the 0. So, and then a bet of $1 is placed on a number. And so if the player wins, gains $500, and if another number selected wins nothing. Okay, find the expected value. So they gave you an example, like let's say you bet on 115. Yeah, it doesn't matter which number. They were just giving you an example there. But again, expected value, so you're making that same chart. Outcomes, gain loss, probability, products. Now, there were a couple homework problems where you didn't need a gain-loss column because it didn't talk about money. So that's what the gain-loss column is for. Like the first example we did in the notes was just rolling the die and what's the expected value of that. All right, so if you play the game, what's the expected value? No, not the gain or loss, but the expected. I said expected value, didn't I? What are the outcomes? Sorry. What are the possible outcomes? You win or lose. Okay, I apologize. So if you win, what happens? Okay, you gain $500. And if you lose, what happens? What's that? Minus $1 is correct. Okay, because it says you win nothing, but it also said you weren't going to get your dollar back. Okay, well, it didn't say that, but you had to assume that you weren't going to get your dollar back. Okay, so minus $1. So make sure you're paying attention to that. It will tell you if you're going to get your dollar back. But if it doesn't tell you, you assume you don't get it back. All right, what is the probability of winning? 1 over 1,000, right, because you select one number out of 1,000. And so the probability of losing? 999 over 1,000. Good, because there are 999 other numbers that you didn't select. So everybody okay with that? All right, so multiplying. So this gives us 500 over 1,000. And then this one gives us negative 999 over 1,000. Don't reduce your fraction, your first one, because you have to add these fractions together anyway. Okay, so when you add, you get 499 over 1,000, correct? And then what does that convert to as a decimal? Okay, 0.499. Is that what you guys got? Good. Because notice we're dividing by multiples of 10, so that's really just move your decimal backwards the number of zeros you have. And so this is money, so we need to round to the nearest penny. Oh, I missed something. Negative, good. So negative, so we have negative 50 cents. So over the long run, one would lose about 50 cents per game played. Okay, so we're going to continue doing probability problems, but this time you're going to be looking for certain keywords, like the words not and or. And then we're going to also look at odds, which is something different than probability. It uses probability, but gives you a little different information. Okay, so the probability of an event not occurring, the probability that an event E will not occur is equal to 1 minus the probability that it will occur. Now, we actually saw this illustrated in the expected value problems, because like in the last problem, you could either win or you lose. So if you know the probability of winning, then you just subtract that from 1, because that would, losing is the probability of not winning, right? It's the opposite there. We saw guilty, not guilty. So either you're guilty or you're not guilty. So the probability, to find the probability of 1, you just subtract it from that total of 1. So 1 minus the probability that it does happen. So if you need a formula per se, the probability of something not happening is 1 minus the probability that it happens. Now, in some of these problems, we didn't necessarily need to know that because, like in the last one about the numbers game, if the probability of winning was 1 out of 1,000, well, we knew that there were 999 other choices, so we used the probability of losing was 999 over 1,000. But really what you were doing was, in your head, you knew that that's what was left to equal 1. So that's what was happening. You were just doing that as a mental step. So if you're dealt one card from a standard 52-card deck, find the probability that you are not dealt a diamond. So first of all, there's a lot of different ways we can do this problem. We can strictly look at what's not a diamond, but you could also just say, well, what's the probability of finding a diamond first? Because that might be easier to think about it that way. So the probability of selecting a diamond would be what? 13 out of 52, okay, which reduces to 1/4. So then the probability that you don't get a diamond, all you have to do is take 1/4 away from 1. So 1 minus 1/4 would be 3/4. So again, you don't have to necessarily do it this way because you could figure out how many cards are not diamonds, but it's probably a lot easier to think about the fact that there are 13 diamonds than how many diamonds there are not, you know, to add up all those other groups of numbers. So your probability here is 3/4. Remember, another way you can look at it is how many suits are in a deck of cards? 4, and diamonds is just 1 out of those 4 suits. So you didn't even have to go with 13. You could have said, oh, 1 out of 4 suits is the probability of selecting a diamond. So therefore, 1 minus 1/4 is 3/4. Now, one thing I want to remind you guys is that you got to think about common denominators here when you're subtracting. And so let me start with this problem, being that it's a little easier. You can visualize this one a little bit better. But if we're doing 1 minus 1/4, so let me show you on paper here. If you're doing 1 minus 1/4, then that means that you needed a common denominator here. So 1 is always 1 over 1. And so to get a common denominator, we're just going to use 4. But whatever you multiply to the bottom, you always multiply to the top. So you have 4 over 4 minus 1/4. So I just want to show you a pattern with the number 1, and it can give you a shortcut later down the line. So then 4 minus 1 is 3 over that common denominator, 4. So if you're doing 1 minus, 3/5, well, again, this is 1 over 1, so what's my common denominator? 5, and whatever you put on the bottom is always going to be the same number up top because it's the number 1. So 5 over 5 minus 3/5 gives you just 5 minus 3, or 2/5. Okay, so notice what really happens is you're really just finding the same difference between the numerator and denominator in that second fraction. So notice 4 minus 1 is 3. Here, 5 minus 3 is 2. So if we did 1 minus 143 over 150, we don't really have to go through the process of finding 150 over 150. The shortcut is, it's just going to end up being 150 over here. So what's 150 minus 143? Bottom number minus the top number is 7. And then you keep the same denominator. Okay, so that's a good shortcut for you because it's always, this 1 is always going to just turn into the denominator. That's what the pattern's going to happen every time. I could have gone through the motions of changing this to 150 over 150, but why? Okay, learn the pattern and save some time there. So if I have 1 minus, 37 over 90, then what do I have to do to find my new numerator? 90 minus 37. Okay, which gives us 53, and then the denominator is still 90. Okay, so use that shortcut as we're doing these problems of 1 minus the probability. Okay, so back to our notes. Okay, mutually exclusive events. If it is impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive events. So, for example, if you're drawing one card, then it's impossible for that one card to be a king and a queen at the same time. So drawing a king or drawing a queen are mutually exclusive events. So if you're trying to find the probability of A or B that are mutually exclusive, then all you have to do is find the probability of A and add it to the probability of B. So for example, let's say you are drawing one card and you are trying to find the probability of selecting a king or a queen. Okay, key word in the problem is or. So not possible for you to draw a king and a queen at the same time. So if we wanted to find the probability of a king or a queen when you draw one card, well, because it's impossible for you to get a king or a queen at the same time, then this is the same as looking for the probability of a king and adding it to the probability of a queen. 4 out of 52, because there are 4 kings out of the deck of 52 cards. What's the probability of getting a queen? Also 4 out of 52. So now, adding these together, we get 8 out of 52, and now we want to reduce. So what do we get when we reduce that? Okay, 2 over 13 is correct. Okay, so the probability of selecting a king or a queen is 2 over 13. Okay, here's another one. If you roll a single die, what is the probability of rolling either a 4 or a 5? Now, what's the key word in this problem? Or. Good. So is it possible to roll a 4 and a 5 at the same time? No. So they are mutually exclusive events, which means we can use that formula. So we need to first realize that we can take the probability of 4 and add it to the probability of 5. What is the probability of rolling a 4? 1/6. And the probability of rolling a 5? Also 1/6. Okay, because there is one of those numbers on the 6-sided die. So then, adding these two numbers together, what do we get? 2/6, but always make sure you've reduced it to 1/3. Good. Okay, so any questions on an OR problem if the events are mutually exclusive? Okay, not mutually exclusive. What do you think that means? No, not the and, just not mutually exclusive. It can happen at the same time, right? So mutually exclusive means that they can't happen at the same time. Not mutually exclusive means they can happen at the same time, like drawing a card and getting a king or a heart. You can get a king and a heart at the same time. Okay, so you guys see the difference there? All right, so if they can happen at the same time, here's how the formula modifies. You're still going to add the probability of the first event plus the probability of the second event, but you also have to subtract the probability that they happen at the same time. So you have A and B, or you could say both if you want, the probability of both. All right, so when you have an OR problem, the key word is OR, you're always going to be adding your probabilities. The only modification to that means that you have to subtract what they have in common. All right, but think about this, that subtracting is still adding, it's adding a negative. Okay, so think of OR is always adding, to remember that. So, you know what, let me go back to this king or a heart so we can illustrate that one. So this time we want the probability of a king or a heart, which means we want to take the probability of selecting a king plus the probability of selecting a heart minus the probability of both, if you want to say that, okay? King and heart at the same time. All right, we already discussed that the probability of a king is 4 out of 52. What's the probability of a heart? Okay, 13 out of 52. And this time it's really helpful to keep that as a denominator of 52. Because remember, you're adding and you need a common denominator. Okay, so minus the probability of both. How many cards are both a king and a heart? Just one. The king of hearts is the only one that's a king and a heart at the same time. So 1 out of 52. All right, so adding, we get 4 plus 13 is 17, minus 1 is 16 over 52. So notice that this was the only time I did not want to reduce yet, not until we get to the very final answer. And so what does that reduce to? Start with a small number. If you've been dividing by 4 so far to reduce. Right, 4 goes into 16 4 times, and into 52, 13, and then that's it. So 4 out of 13. It was the probability that you would get both of these at the same time. So the only time that you end up with a card that is a king and a heart is the king of hearts. So there's only one card that has both a heart on it and is also a king. And so that's where that last one came from. In a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. If one student is selected at random, find the probability that the student takes math or psychology. So what is the key word here? Or, and then you have to ask yourself, is it possible for the student to take math and psychology at the same time? Yes, okay, so it's not mutually exclusive. That means you must subtract that part. All right, so working out our formula, the probability of math or psych means that you want to take the probability of math plus the probability of psych and subtract the probability that they're taking both math and psych at the same time. Okay, what is the probability that a student takes math? 23 over 50, good, because there are 23 total students who take math. What is the probability that the student takes psych? Okay, 11 over 50. Okay, and then the probability that they take both? 7. Yeah, I'm not putting it into the formula quite yet, just identifying each probability individually. Okay, so plugging it into the formula, then you have 23 over 50 plus 11 over 50 minus 7 over 50. Okay, so I got 27 over 50. Everybody agree? Does that reduce? Nope. So that is your final answer. Okay, so these were all problems that had a keyword of or, and then you had to ask yourself, if they could not happen at the same time, you're just adding the two probabilities together. If they can happen at the same time, then not only are you adding, but you're subtracting that possibility that they have both. Okay, the next thing we're going to look at is odds. There are two types of odds. There are odds in favor and there are odds against. So the odds in favor of E are found by taking the probability that E will occur over the probability that E will not occur. So if you don't have your handout, this is really the most important part, the formula right here, because it's what that is. The formula is what that says in words. Okay, so the odds in favor of E is P of E over P of not E. P of E over P of not E. Notice that not comes into play here. And we already discussed how to find the probability of something not happening. That 1 minus. Okay, so the odds against are found by taking the probability that something would not happen over the probability that it would happen. Okay, I heard the word reciprocal. Very good math word. Good. Some people just motioned that you were flipping it. Okay, other people said flip. Okay, but good. Good math word, reciprocal. All right, so these two things are just fractions that are reciprocals of each other. All right, so the odds against E can also be found by taking the reciprocal of the odds in favor of E. So if you've already found the odds in favor of something, you don't have to work out the formula again. Just flip your fraction over, find that reciprocal. And you want to find the odds of rolling a number less than 4. You know what? I'm going to change that to less than 3. Actually, no, I'll keep it. Less than 4. Okay. Sorry. All right. So single die roll, odds of rolling. Okay, and I didn't say what kind of odds, did I? So let's say odds in favor of. So odds in favor of rolling a number less than 4. All right, so first of all, in order to find, so it says odds in favor is the probability of E over the probability of not E. Okay, that's your formula. So we have to first find the probability of a number less than 4. Okay, how many numbers are less than 4? 3 out of 6, so that reduces. Try again. 1/2, good. All right, so our numerator here is 1/2. All right, so then what's the probability of not a number less than 4? This is just 1 minus the probability that it did. So 1 minus 1/2 is also 1/2. Don't overthink this one. Okay, so the probability of getting a number that's not less than 4 is 1 minus the probability that it is less than 4. So 1 minus 1/2 is 1/2. So that goes in the denominator here. Okay, so the thing about this is that you've got a complex fraction. You have a fraction inside of another fraction. So what I want you to remember is that this fraction bar is also a division symbol. So this is the same as 1/2 divided by 1/2. And so this is, so you would have 1/2 times your reciprocal of 2 over 1. What happens to our 2's? Okay, but here's the thing. Even though your answer is 1, in an odds problem you need an answer that's in the form of a fraction. So it's 1 over 1. Okay, and I've run out of space here on my paper. Yeah. Okay, so it's 1 over 1 because the way that you're going to write your answer for odds is one of two ways. You're either going to write it in words that says the odds in favor of rolling a number less than 4 is 1, 2, 1. Okay, you've got this word 2 in between, and so your numerator 2, your denominator. That's how you always fill in your answers, numerator to denominator. The other way that they might ask you to write it is with a colon in between. And you'd say 1, colon, 1. Same order of your numbers, but then the colon means the word 2. So 1, 2, 1. Meaning for every number less than 4 that you roll, you can also roll a number greater, 4 or greater. It's 1 to 1. So it's, you know, again, for every 1, 2, or 3 you can roll, you could also roll a 4, 5, or 6, 1 to 1. All right, let's do a different one. If you were finding the odds in favor of drawing a king from a standard deck. So the odds in favor, remember our formula, is the probability that that would happen, probability of a king, over the probability of not getting a king. So what is the probability of getting a king? Okay, 4 out of 52, or you can reduce that to what? No. 1 out of 13, okay? So we'll use the reduced answer. And then the probability of not getting a king, okay, 12 out of 13 is correct. Because remember, you're doing the 1 minus 1 over 13. Okay, probability of something not happening is 1 minus the probability that it did. So 12 over 13. All right, so remember that this is a division problem, 1 over 13 divided by 12 over 13. Or what you're really doing is the numerator multiplied by the reciprocal of the denominator. What happens to my 13s? They cancel, and so I get 1 over 12. So the odds in favor of a king is what? 1, 2, 12. Good. For every king that you can pick, there are 12 other cards that are not kings. That's really what it's telling you, what odds are telling you. All right, so what are the odds against? Okay, good. Odds against a king is 12 to 1 is correct, because remember that the odds against are just the reciprocal of that previous answer. So you're just flipping your numbers over. No need to work the formula all over again. Now, if it never asked you for the odds in favor and it asked you for the odds against, then you would use the correct formula for odds against, okay, putting the not on top and the probability that would happen on the bottom. Okay, so that's when you don't know the odds, but you know the probability of something. You're also going to take a look at problems when you know the odds, but you don't know the probability of it happening. So if the odds in favor of an event E are A to B, okay, we've gotten used to that pattern now, A to B, then the probability of the event is given by this formula. So if you have to go backwards and find what the probability of that would have been originally, you just take your A and put it over A plus B. Now it's very specific. Which odds do you need for this formula to work? In favor, right. You need the odds in favor for this particular formula. So if you're given the odds against, what do you have to do to those numbers first? Flip them, right, flip them. And then you can plug them into this formula. All right, so let's go look back at this problem for the king. So we just learned that the odds in favor of a king was 1 to 12. We don't want the odds against, we want the odds in favor for this formula. So therefore, the probability of a king should be A over A plus B, and this is your A and this is your B. The first number is your A, the second number is your B. So that means that we would have 1 over 1 plus 12. Well, what is 1 plus 12? 13. 1 over 13, which is correct. We already knew that. That's why I want to do this problem. So we got back to the probability of a king, which was 1 over 13. Okay, so taking a look at this problem, it has a chart that shows you the income distribution of households in millions. So, for example, the number of households that have an income of less than $10,000 a year is 14, but that means 14 million. Okay, so these numbers are already in millions. So what it wants you to do is find the probability that the household income is not in the 15,000 to 24,999 range. Okay, what was the key word that I just said? Not. Okay, let's see if it's letting me right here. Okay, so we're looking for not in this range. Now, there are two ways that you can do this now. You could add up all of the numbers that are not in that box, or you could just find the probability that you do get this first. So finding the probability that they are in the 15,000 to almost 25,000 range, which means we look at this row only, and that's 5, and it already told you what the total was up here. It says it's the annual income of 84 million households. So you already know that's the total. If you added them all up, you should get 84. So 5 out of 84. So therefore, if I want to find the probability that it's not this, what would I do? Not flip. Subtract from 1. Okay, so the key word not says do 1 minus this probability. Now remember, we learned a shortcut that we're always going to be taking the numerator from the denominator. So 84 minus 5 is 79, but you have to keep that same denominator of 84. So that was our shortcut. And then you have to see if 79 over 84 reduces, but I have a feeling it doesn't. Okay, so if you see the key word not, that means you can find the probability that it does happen and subtract that probability from 1 as your shortcut. Now sometimes there aren't two ways. That's the only way you can find it because they didn't give you any other information to do it. So you have to take the probability that it happens and subtract it from 1. All right, let's see if we're right here. So 79 over 84. Nice work. Okay, you randomly select one card from a 52-card deck. Find the probability of selecting the 2 of diamonds or the king of hearts. What's the key word in this problem? Or. Okay, so whenever you see an or problem, you have to ask yourself, is it possible for these two things to happen at the same time? No is correct. So, so you're saying, can I draw one card and get a 2 of diamonds and a king of hearts at the same time? No. So therefore, you are just adding your 2 probabilities. You don't have to worry about also subtracting. So the probability of a 2 of diamonds or a king of hearts means we're just finding the probability of a 2 of diamonds plus the probability of a king of hearts. Okay, what is the probability of selecting a 2 of diamonds? 1 out of 52. There's only 1 2 of diamonds in the deck. What's the probability of selecting a king of hearts? Also 1 out of 52. So adding, you get 2 out of 52. Does that reduce? Okay, 1 over 26. Okay, so 1 over 26. Good job. Okay, so the table shows the educational attainment of the population of Mars, ages 25 and over, expressed in millions. Okay, so apparently they take a census there as well. All right, find the probability that a randomly selected Martian age 25 and over has not completed 4 years or more of college. Okay, what's the key word in this problem? Not. Good. All right, so the shortest way to do this is to first find the probability that they did complete 4 years or more of college, and then do what with that answer? Subtracted from 1. Good. So the totals have already been done in this chart. You guys have noticed in the other sections it's not always totaled up for you. You have to sometimes work that out. So take a minute, look at those numbers. Good. Just look. Okay, so the probability that they have completed 4 years or more of college. And what did you find? Well, 160 is the total. How many have completed 4 or more years of college? 39. Okay, 39. So you got 39 out of a total of 160. Okay, so the probability that they have not completed 4 or more years of college is 1 minus this. But again, the shortcut, remember, is just to take 39 from 160. So what do you get? 121 over 160. Does that reduce? This is where it becomes of value to have a calculator that does it for you for time's sake. But again, you can just try a few numbers. Well, it just depends on your calculator. So that's not something that I show because every calculator is different. Plus, you're supposed to have the skill of reducing a fraction in here. I'm going to say that it does not reduce. And here's why I think it doesn't reduce. I'm taking a look at 160, and I see that that's divisible by 2. It's divisible by 5. Any multiples, you know, there are multiples of 2 that it's divisible by, like it's divisible by 4, and it's also divisible by 10, and so on, okay? But if I look at 121, that's not divisible by 2, and it's also not divisible by 5, and so I'm guessing that, you know, if I actually work this out, I could, you know, I could test this out. And in your calculator, you could do 121 divided by, you know, whatever. But so on, you know, and if you know 121, you know what the multiples of 121 are. 11, right? 11 times 11 is 121. So if that's the only factor of 121 other than itself, 11 does not go into 160. And so you know it's not reducible. Okay, there are some little things that if you know, just really focus on the numbers, you could do that in your head rather quickly. All right, so you've got 121 over 160. Well done. Okay, now it says same information. The numbers have changed though. But what's the probability that the selected Martian age 25 and over has completed 4 years of high school only or is a male? So has completed 4 years of high school only or is a male. So what's the key word here? Or. And is it possible that they have completed 4 years of high school only and be a male at the same time? Yes, so these are not mutually exclusive. Okay, so the probability of high school only or a male means we're looking for the probability of high school only plus the probability of being a male. But because it's possible that it can happen at the same time, we throw in that minus the probability of both. Okay, so what's the probability that you select a Martian that has had 4 years of high school only? Okay, 60, the total here. Remember, this is just high school. It has nothing to do with being a male here. So 60 over the total, 172. Okay, then the probability that the Martian you've selected is male. Any male, doesn't matter. This one only focuses on being male, doesn't focus on their education. Yeah, which it's already been done for you. So yeah, so 83. And so you have 83 over a total of 172 minus the probability that it's both a male and only finished 4 years of high school. Okay, so that's where you go for the 28, right? So this is the number of males that have 4 years of high school only, 28. Over the total, 172. Okay, any questions where we got those three numbers from? All right, add and then subtract. 115 over 172. Okay, does that reduce? Okay, so I'm going to say that that is as reduced as possible. And so 115 over 172, any questions before it disappears? Okay, so Carol speaks for all of you, so I'm going to put it all in there. All right, so 115 over 172, right, that's what we had? Well done. All right, so here you have a bar graph of active duty military personnel. The purple columns are showing the men, and the pink columns are showing the women. And then it's divided by branch of service, Navy, Air Force, Army, Marines. And so it shows you how many men or women are in the Navy, or how many men or women are in the Air Force, and so on, in thousands. So it says, find the odds in favor and the odds against that the person being, that person being a man in the Army. Okay, so if you select somebody at random, you're finding the odds in favor first of selecting a person that's a man in the Army. All right, so looking at here, we're looking at odds and favors. So this means that we're looking for the probability that it's a man in the Army over the probability that it's not a man in the Army. Okay, so finding the probability of a man in the Army. What do we have to do? Yeah, you got to add what? All of it. Good, because you have to find out what the total population is here in order to find the probability of something. Okay, so we're adding 320 plus 80, which is 400, plus 300 is 700, plus 10 is 710, plus 420, so that would give us, let's see, 730, and then another 4 is 1130, plus 60 is 1190, plus 170. Okay, so I heard 1360. Okay, so then plus the 70 is, we'll say it again, 1430. Okay, so now that we have the total population, we want just a man in the Army. So how many men are in the Army? Okay, 420 over the total 1430. Now that can reduce. I know right away because they both end in a 0. Okay, so if you want, you can cancel out the 0. I don't know if it reduces any further, but I'm going to say it doesn't. So, all right, so if this is the probability that you've selected a man in the Army, now we have to find the probability that you don't select a man in the Army. So what do we do with this 42 over 143? Subtract it from 1. Good. So 1 minus 42 over 143. Okay, 101 over 143. Well, we haven't finished this one yet. Okay, so now that we have our probabilities in place, This is really the same as 42 over 143 divided by 101 over 143. But again, most of you guys are going to see this pattern and just skip to the next step of 42 over 143 times 143 over 101, because you're multiplying by the reciprocal there. Okay, so what happens to the 143s? They cancel, and we have 42 over 101. Okay, so notice this time instead of the word 2, they have the colon. So they want you to put the numerator in the first box, colon, the denominator in the second box. Typing in 42 was our numerator, right? And then 101. Whoops, 101. Nice work. Okay, so now the odds against. Good, reverse the numbers. So 101 to 42. Well done. Okay, if you are given odds of 2 to 3 in favor of winning a bet, what is the probability of winning the bet? Okay, so this time you're given odds and you need to find probability. So what was the formula for that? Yes, the A over A plus B. Good. Were we given odds in favor? Yes, because that's what we need for this formula. So the first number is your A and the second number is your B. So odds of 2 to 3 means that we plug in 2 over 2 plus 3, and that gives us 2 over 5. So the probability of winning the bet is 2 over 5, where the odds are 2 to 3. There are going to be a couple of problems where it asks you to take that formula just a little step further, maybe has you think of it in a different way. So just, start from that process and work your way there. All right, so that covers section 11.6.